So for this video, we're gonna go over some more simple harmonic motion concepts and then finish with example problem number 35. So, first I want to talk about just what amplitude is. We talked about it in the last video a little bit. Just amplitude is, here I'll draw a little sine curve. Say that's, yeah, so amplitude is just here, this here, so of course in this it's 15, but yeah, so pretty much that's what amplitude is. And now I want to talk about velocity and acceleration for simple harmonic motion. So we have the exposition function of, here as you can see, a cosine wt, so that's going to be angular velocity. Then we can derive it by just taking the derivative of time, dx dt. So all we do is take the derivative, and then we'll get velocity to equal negative amplitude angular velocity times omega times sine times omega t. Alright, so now of course we just take the dv over dt derivative again if you want to get acceleration, and that's equal to a squared cosine t. Alright, so yeah, so pretty much this right here just shows the relationship between exposition or displacement, velocity, and acceleration. So this also shows that the max acceleration is just going to be negative a delta squared. So now what we can do is we're going to look at our example problem. Which of the following statements is true of the magnitude of the acceleration of the object at time t equals 1? It is equal to 0, it is equal to g, it has minimum value that is not 0. It has a maximum value. It has a value between 0 and its maximum value. So at time, if we look at our diagram that we wrote, at time t equals 1 second, it's gonna look like this, pretty compressed, and up here at y equals 15, and where this is the equilibrium point. So it's gonna be all the way compressed as it will be. So to find this, we can use you can use this equation, or you can just think about it like this. So pretty much it'll be at the top on its way back down, right? So pretty much when it's going to be on its way down, it'll have a negative acceleration, but remember, because the spring doesn't move at a constant speed up and down, so the acceleration will be changing. So at that point, the acceleration is not 0, but the acceleration is speeding up and then eventually slows down. So at this point, t equals 1, the acceleration is not equal to 0, because that would mean acceleration equals to 0. That means it's moving at a constant speed. But it's obviously going to be a small value, not 0, and it's likely increasing. So now we look at 35 and we see answer A, nope. Answer B, no, because it's changing. It has a maximum value that is not 0. C looks promising. Has a maximum value, nope. Maximum value would be at the middle, at the equilibrium point. And then has a value between 0 and its maximum value. So the answer is C here, because it has its minimum value, because it's just starting to go down, and it's not its maximum value, it's just starting to go down, and yeah, so the answer is C.